Hello everyone, welcome back. In this video, we are going to learn another important concept, that is Java multithreading, with a clear explanation and practical examples. Subscribe to the channel to keep learning and growing your Java skills. Now let's get started. So, have you ever wondered how an application can download a file, play music, and still respond to your clicks all at the same time? And also, how can a web server handle thousands of requests without waiting for one request to completely finish before handling another request? So the answer lies in one of the most powerful concepts in Java multithreading. Okay. So in this video, we will understand what multithreading is, why we need it, and how threads work inside a Java program, and where multithreading is actually used in real-world applications. So by the end of this video, you will have a clear foundation before we start creating and working with threads in Java. So before understanding multithreading, let's first understand the problem it solves. So imagine our application has 3 tasks. It can be any task, okay? So let's say first task, download a large file, okay? So we have 3 tasks. First task is downloading some large file, okay? And second task, it is processing some data. And third task, let's say it is responding to some user action. Okay, so if these tasks execute one after other, the second task may have to wait until the first task finishes, and the third task may have to wait even longer. So for some applications, the sequential execution can make the program slow or unresponsive. This is where threads become useful. Okay, so now we will see. Okay, so this one we have covered. So without multithreading, if we are seeing like we have different tasks, so one task executes at a time and other task may have to wait. Okay, and suppose if first task is long running task, it is taking too much of time, then remaining tasks have to wait, and it will affect responsiveness. Okay, so a thread is what? Thread is a lightweight unit of execution within a process. So you can think of a thread as an individual path through which instructions are executed. Let's say when we start a Java application, it runs a process. Okay, and inside that process, we have multiple threads. Okay, so inside process, we will be having different threads, okay, performing different tasks. So let's say thread 1 is performing something other task. So all threads will be performing some different tasks. Okay, so these threads belong to the same process and can share resources such as memory. What does it mean? That means these all threads are performing some tasks, but those tasks are related to one process. And I am saying these 3 tasks are communicating or utilizing a single resource. Resource can be memory or data or something or anything else which is being shared between all these 3 threads. Okay, so instead of having only one path of execution, our application can have multiple paths of execution. Okay, so thread is what? It is a lightweight unit of execution. Multiple threads can exist within one process, and threads share process resource. Okay, so thread is nothing, just a path of execution. How these task will get completed, so it will have a different path. Okay, now what is multithreading? So Multi-threading is the ability of a program to execute multiple threads concurrently. So for example, one thread might download a file. Okay. Another thread might process a data. And while another thread handles, let's say, user interaction. So instead of forcing every task to wait for the previous task to complete, multiple tasks can make progress during the same period of time. Okay, so this all three tasks can be completed during same period of time. So this allows us to build applications that are more responsive and can use system resources more efficiently. Why I'm saying more responsive? Because we can perform three tasks at the same period of time. That means we don't need to wait. The application will respond immediately, or might take some time, but as compared to the sequential execution, it will respond faster way. So that is an advantage of using multi-threading. Okay. So multi-threading is executing multiple threads concurrently. Okay. Now we will see the difference between concurrency and parallelism. So there is one important distinction we should understand. So concurrency and parallelism are related, but they are not exactly the same. Okay. So concurrency means what? Concurrency means multiple tasks can make progress during overlapping periods of time. So concurrency means multiple tasks make progresses over time. Okay. You can think like we have like different threads are there. Okay, different threads are there. They are performing different tasks. Okay, but CPU, we have CPU. Okay, it is switching between these threads very rapidly. Okay, giving us the appearance that multiple tasks are running together. Okay, let's say T1, T2 and T3. T1 needs some CPU utilization, T2 needs some CPU utilization, and likewise T3. Okay, but CPU is distributing the CPU, memory utilization or CPU utilization in such a way it looks like these all threads are working at a time, running together. Okay, but parallelism means what? Multiple tasks are literally executing at the same time. That is parallelism. Execute simultaneously. Okay, here there is a switching. For concurrency, switching between T1, T2 and T3, but it is happening very fast that it seems like, okay, it is occurring at the same time. But in parallelism, it literally executes at the same time. Okay, so it uses multiple CPU cores for parallelism. Yeah, multi-threading can help us achieve concurrency. Okay, concurrency. And depending on the hardware and the application, threads may also execute in the parallel. Okay, for parallel we should have a multiple CPU cores, then we can achieve parallelism. Okay, now why do we need multi-threading? Okay, so the first thing is it can improve application responsiveness. Responsiveness means what? Responsiveness means if one task takes a long time, other threads can continue doing useful work instead of making the entire applications to wait. Okay, that means let's say if you have performed one task T1 and you are performing another task T2, so T2 will not wait to completion of T1. It will start simultaneously. Okay, making the application responsiveness. So, and second thing is it can help utilize system resource more efficiently. So efficient resource utilization. Resource can be memory, database. Okay, so Modern computers have multiple CPU cores, and properly designed multi-threaded applications can take advantage of them. Okay. So, and third, it allows application to handle multiple independent tasks concurrently. That is concurrent task execution. So these are the like requirement for which we use multi-threading. Okay, so multi-threading does not automatically make every program faster. It introduces additional complexity, and it should be used when the nature of the application actually benefits from the concurrent execution. So we should identify, okay, this concurrency is required as part of this application. In such cases only we should use multi-threading. So we should be clear with our requirements. So it improved performance in suitable tasks. So that's why we need multi-threading for better responsiveness, efficient resource utilization, and concurrent task execution. So let's see some real world examples. Okay. So consider a web server. Okay, web server, and it is receiving a request from many users, multiple requests from many users. Imagine if the server could process only one request at a time. Every other user would have to wait until the previous request was completely processed. Okay. So let's say we have different thread for different request. So for request 1, we have different thread, likewise for 2 and 3. Okay. If you are sending some request, then each thread will be handling those requests. Okay. And every other user would have to wait until the previous request was completely processed. So application use concurrent processing so that multiple requests can be handled efficiently. Okay. So multi-threading is one of the fundamental concepts behind building responsive and scalable applications. Okay. Although modern Java applications may also use thread pools and other concurrency models, rather than simply creating only one thread for every request. We'll see in the later videos those things. But multiple requests handled concurrently. Okay. Now we will see, okay, here is something interesting. So even if you have never explicitly created a thread in Java, you have already been using one. You must be saying how we are using one. So when a Java application starts, the JVM runs our main method. This is the main method. Okay, whenever we start the application, the main method will get start. Okay, so the main method using a thread commonly called main thread. Okay, so main method uses one thread named main thread. So every Java program already begins with at least one application thread executing our code. So by default, we have the main thread which will be executing our code. Then from there, we can create additional threads to perform other tasks concurrently. Okay, so in the upcoming videos, we will see exactly how to create and manage those additional threads. Okay. Now, okay. So the easiest way to remember the concept is this. In a single threaded flow, we have one path of execution, performing work sequentially. Okay. So path of execution is what? Path of execution. Path of execution means what will execute when. Okay. So task A will complete, then task B will execute. Task B will complete, then task C will execute. So there is a sequential approach for single threaded sequential approach. Okay, it will work sequentially. But with multi-threading, we can have multiple threads representing multiple paths of execution within the same application. Okay, so here we have only single thread. Single thread means only one thread which is fulfilling all these three tasks. But for multi-threading, we have different threads for performing different tasks. Okay. So these threads can perform different tasks concurrently. This is an important point. We have multiple threads and these can perform concurrently. But once multiple threads starts working together, some interesting challenges appear. Okay, what happens if two threads try to modify the same data at exactly at the same time? Okay, so let's say we have one common resource. Okay, and let's say we have two threads T1 and T2, and both are trying to utilize the same resource. Then what will happen? That is where multi-threading becomes really interesting. Okay, so in this video we learned that a thread is a path of execution within a process. So one process can have multiple threads, and multi-threading allows multiple threads to make progress concurrently. We also understood why multi-threading is useful and where we see it in real-world applications. But now comes the practical question. How do we actually create a thread in Java and make our own code run concurrently? That is exactly what we will learn next. So that's all for this video. I hope you now have a clear understanding of the multi-threading. Thanks for watching, and I will see you in the next video.